Good morning. Welcome to this morning session. I hope you had a good rest after the social event. The first session is about tooling mostly, because RISC-V would be nothing without tooling. So welcome to our speakers. I have an update for you. You have water on this table if you get dry. And our first presenter is Stefan Wallentowitz. I will introduce you, but I think everyone knows you. You're professor of computer engineering at the Hochschule München Applied University of Science, and you serve as the vice chair of the RISC-V International, and you're the director. You are director at the FOSSi Foundation. So the floor is yours.
Thank you. Good morning. I hope you're all awake. I was invited to speak a little bit about the open source part of my work. So, as you all know, RISC-V is not necessarily open source, but I'm very active for over 10 years now in the whole open source silicon ecosystem. And that's also, I want to just roughly recap my career, but not the professional part, more the advocacy part. So during my PhD, I already got involved with OpenRISC. I think I mentioned it on a panel 2 days ago, which was an open source processor and an open source ISA that everybody forgot because RISC-V appeared at some point in time. And I had this need, because I was doing my PhD, I wanted to prototype, right? I needed RTL to improve, right? If I do microarchitecture improvements, I need something to improve on. And that was the reason for me. I got very deep into this, became a co-maintainer. Out of this, we formed the FOSSi Foundation because we saw the need to have like a body similar to what you have at Linux Foundation, etc., focusing on free and open source silicon. That's FOSSi, what it is for. And that's also how I got more and more involved in RISC-V and currently serve as a vice chair of RISC-V. So I have my whole career, like you see, I was mostly in academia, spent a few years in the smart card industry, always also with the ambition and the vision that open source could be a good solution to people that are in need and want to experiment, want to innovate. And that's also how I got my career in industry for a couple of years. So why do we even speak about this? So if you look back across the globe, ignited by the supply chain shock 5 years ago now, and the geopolitical challenges, we saw that there are a lot of ambitions arose across the globe on more investments in chip design, more discussions around sovereignty. If you look at the European strategy, you can see that chips are a strategic asset, actually. So they are mentioned as a strategic asset, and they are a key ingredient to the digital transformation, which is also what ultimately leads to the CHIPS Act in Europe, right? So we have the CHIPS Act now for a couple of years. Yesterday, Georgi and Alexander also spoke about the joint undertakings part in it. And we see a lot of investments in public-private partnerships, public funding, and new strategic policies developed. Like, so the CHIPS Act money that we talk about mostly, there's some strategy behind it. And so we have a very strong ambition in Europe to catch up in terms of chip design, right? Like chip production is one topic that Pablo also talked about yesterday. But also in terms of design, there needs to be more and more involvement of academia, of industries, SMEs. So we need to create this large funnel, right? So if you want more startups, if you want more people in industry working on chip design, and that's also why I introduce it that way, I think where open source can play an important role. So we have a lot of funding now via the CHIPS Act. I'm from Germany. We have a lot of funding via our national ministry in chip design, also especially on open source chip design, as part of the strategy to close the gap, to get more designs out of Europe. Just a little bit of background. So if we think about chip design, and I think that's how I would currently see the two main drivers for me. The one is the sovereignty part, and the other one is the innovation, actually, right? Like, we shouldn't speak about chip design only as like, oh, we need to do this because otherwise somebody else does it, and we need this, whatever. I think we should think about new designs that are innovative, right? It's not about replacing one existing chip with another. It's about like the domain knowledge that we have in Europe for the European industries, key industries, and apply the knowledge and do innovation in chip design. And I think those are the two aspects that make it very interesting to think about open source chip design a little bit. And I just want to give you a brief overview of where we are, especially in Europe. Just to differentiate, like we have RISC-V, and it was for a couple of years. I think the first 6 years it was very hard to always remind people that it's not open source, right? Like the RISC-V is an open ISA, it's an open standard, and there's open source and proprietary implementations. And I think for a couple of years it was very hard, like especially if you talk to press, they all assumed this is an open source processor, right? There's open source processors, they are great, but in general it's an open standard that enables open source. And I think on the one hand that was a little bit of an issue for some time, that it was always like also misinterpreted this way by the public. But it was also good in a sense that there was some truth to it. So open source implementations were always key factor for RISC-V success, I think, right? Like, because it made it very easy for companies to engage with RISC-V without the burden of like engaging with the IP providers at the beginning, right? And sign NDAs for a couple of months. Just download something and get started, play a little bit around. I think a lot of the projects started with open source IP and then went into more commercial IPs later, or proprietary IPs. So there's a good value. I think we need reference implementation of open source. It's always great. You can always find your RISC-V core implementing all the standard extensions that you need. And it's also like, if you think about research, obviously, there's the success in research of RISC-V can also be hugely attributed to the vast existence of implementations across 32-bit, 64-bit. You have all the different cores available. So I think open source has an important role in RISC-V, and I would like to broaden a little bit and speak about open source in general. Especially in Europe, like we had very strong groups from the beginning. If you think about the Pulp team, for example, if you think about various other academic groups, but also industry groups, there was a strong involvement in the open source community in RISC-V, driving the availability of RISC-V cores. And Europe has always been very strong in this aspect. And I think, in general, it would be important that we play a more key role in open source chip design in general. So last year, Frank Gökaniak from ETH Zurich gave this presentation. So there's a slide from his presentation last year where he spoke about the model that the Pulp team and especially ETH are doing with the industry collaboration. It's a very interesting talk. If you didn't see it last year, you should you should watch it on YouTube. He was speaking about their model, like how they do everything open source, but then engage with industry on specific projects, have all the tapeouts that they're doing. They have a couple of tapeouts every year. And he spoke about like a very simplified view, of course, of the chip design toolchain. But he highlighted, like, if you look at all the arrows, like your entire path to the design process, actually you have open source tools now, right? Like you have open source tools, you have open source PDK. So he highlighted a little bit what are the parts that they focus on, you can see, but also like what's the road that they usually take for the design process, and then also where they try to employ more and more open source tools because it makes it easier for them to work with industry also, but work with the students. And I think this is a very good overview. It already highlighted some of this, and over the last year, a lot has happened around this area. What he announced last year, he was saying we are getting there. The first fully open source chip is on the way. I will come back to this in 2 slides because actually it happened now. I want to categorize it roughly for you. I think that's important to understand. If you speak about open source chip design, there's essentially 3 categories that I would distinct. One is the open source design IP. I spoke about a little bit already when I speak about RISC-V, right? Like you have a lot of, that's everything that goes into the chip, right? You have a lot of IP available that you can build your chip on. Then you have open source EDA tools. This is essentially the tools that you need to design the chip, right? You put your IPs into these tools and together with your own RTL, and then you get out your chip design. But it's also important, if you speak about open source chip design, to think about the manufacturing and production. And this is where you need, or like might need a PDK at some point in time. There's a process design kit. There's a large number of proprietary process design kits. But there's also this thing that essentially started like roughly also 5 years ago. We see more and more investments into open source process design kits, PDKs. So those are 3 different areas, and I don't advocate that you need to be in the middle here, right? You should have a look at in all of the circles, right? I don't say like all chip design has to be in the middle. I just say if you are new to chip design, there's some value in exploring all the existing IP, all the EDA tools, and have a look at the available PDKs. And also, if you're an SME, there's some value in exploring a little bit and think about if you can take some shortcuts, also in terms of time. So you can land in the middle, but everything is great. If you can be outside, that's good, but if you're in any of those circles, I think there's a lot to learn. There's a lot of stuff that you can actually build on. I just want to highlight now, like in the middle, you had Frank's slide, and they actually did this last year. This year, they have it outside at the booth. You can see the Basilisk chip. It's a fully open source chip. There's all the IP that's in there is open source. They only use open source EDA tools. They use an open source PDK. So it is end-to-end, fully open source application class system on chip. It runs Linux outside. You can see at the booth. And you can download the GDS2 and put it into production yourself. You can download the RTL, modify it, run the same scripts to the same tools, come to the same result, improve on it, and I think it's really great. So the design is essentially a CVA6 RISC-V core, which is the open hardware 64-bit implementation. They used essentially like the standardized flow based on OpenRoad, Yosys, etc. And they manufactured with the German IHP fab, which is a 130 nanometer bi-CMOS PDK, but they did it, I think, in the CMOS process. So I think that's a great success story. I think it also demonstrates and it validates the whole concept, especially if you're in academia, if you are in industry R&D, if you're an SME. This is, I think, something that demonstrates to you that it's worth having a look if you just want to play around, if you just want to do some smaller efforts just to get going, right? I think, and this is what we need if we speak about the CHIPS Act, right? It's fine, it's good that we should extend the capabilities that we already have, but we need more people just playing around with it, and I think it really demonstrates that we can get there. If you compare it to open source software, of course, everyone knows or agrees in this room that chip design is a little bit more complex. I think this was also like two-spin design, right? The first spin, I think, took some time and didn't get through. Like in open source software, it's very successful because you just put it on GitHub and you improve it all the time, right? If you build a chip, you know, like the traditional chip design flow is very different from the normal pull request-based GitHub flow where you just, when you have a bug, you just fix it and you re-release the software, you deploy it again. That's definitely not what you can do in hardware, right? But we've already seen for the last roughly 20 years this whole hobbyist maker scene, right? So there's some first experience in hardware, which is of course different than silicon design, but you see some uptake there, right? Like you see people adopting it, building on designs of other, like this whole maker scene is really taking up. In silicon, we are pretty, I would still say like in early days, right? Despite we already see some successes, I think the complexity of chip design makes it very hard to have like a vivid, like open source community where everyone can just come in, build their chip, modify it, etc. That's very different, but I would still think like that there's a good trajectory that would follow the other trajectories. So why do we need open source chip design for Europe? And that's, I think, the main drive also to what how I motivated my view on the CHIPS Act. So there's two major problems that we have in Europe, right? So one is the accessibility to SMEs and newcomers, right? Like if you, like I studied in the 2000s and everyone told me chip design is done in China, right? Like you can learn like system modeling, you can learn all the great stuff, how to integrate systems, but we're not designing chips anymore. And I think at many universities, like in Germany and across Europe, the idea of a tape out just in the recent years came back, right? And so we have many people that are actually newcomers like me. Like I studied electrical engineering, but the actual work on chip design just started much earlier. I work in a computer science faculty. The students have all the great other opportunities, but I want to convince them, right? That's an interesting thing. This is something where you can innovate, where you can play around. And I think open source, those 3 components that I spoke about, are very interesting because it removes the burdens, right? Like if I tell my students, oh, there's an air-gapped computer that runs the software that looks a little bit outdated and you cannot take it home with you and everything is complex. And on the other hand, they have all the great AI PyTorch things that they can do at home. I think that's not very appealing. If I want to convince them to think about chip design, I strongly believe that to get more people interested, we need very easy accessibility of tools, of the process design kits, etc., just to steer them. Like, otherwise, they will not get interested, I think, right? There's a lot of other opportunities in computer science, especially, and I want them to think about, to play around, and in my courses at the moment, all of them have to just run an open source flow from beginning to end in 90 minutes, right? Like, just that they can see, like, this is of course not the next NVIDIA killer, right? But this is like getting my freshmen interested in chip design at least a little bit. Also the same, I think, applies to SMEs. I had a brief career in industry, but my main role was always there to explore how they can engage in chip design as more traditional software companies. And I think open source makes it easy for SMEs just to play around, to experiment a little bit. Also, especially in domains in Europe, 130 nanometers is not a very bad choice sometimes, right? So you can just do a tape out just to find out if this is something that your company should do, wants to do, etc. We want to nurture a talent pool, right? That's the other aspect in Europe. That's one of the ambitions also if you look into the CHIPS Act. We need more skills and talents. We need more productivity. So if you want to attract more talent, this should not be, there should be no barriers. There should be more people just playing around with it and getting interested, right? I think those things are very important, and I think that we have a direct impact of open source that we can leverage to build a larger pool of talent and to reduce the accessibility, to increase the accessibility, remove burdens into the design. And one aspect that I also find very important, especially if we talk about open source EDA tools, like, it's the first time that students, again, can even look into the tools, right? I had students during my classes opening pull requests on my own EDA tools, right? So they looked at the source code, they found some inefficiency, they found some bug. I think this is also very important, right? If you speak about creating a talent pool, it should not only be people that know how to use the tools, but also know how the tools work. Right? And this is very easy if you have open source EDA tools that are well established and that you can build on. If you look at open source design IP, I think I already spoke a little bit. We have a very strong history in Europe, actually. So the open RISC community was mostly based in Europe. It was a project out of Europe. At the time, we also had Leon, which is also now Front Geisler, right? It was the Geisler community. That was already there 25 years ago, right? Like, it started in the late 90s, and it was always a very strong and vivid community in Europe, right? It was not a large community. And we saw a significant boost with FOSSi, and I think this is something that we should be able to leverage on a little bit more. So we see a lot of, especially in Europe, academic and industry R&D, right? Like, those are the two areas where I see also strong interest in open source design IP. You saw yesterday the presentation by Georgi on the CHIPS EU activities. We also have the other activities in the Euro HPC, where open source IP is now created and built on, and platforms are built on to enable the European industry to collaborate more openly on open source IP, and then getting to the next step of commercialization, right? And this is where those projects, and you can also see a clear path going from like the PowerUp team over the non-profits, low risk, and the Open Hardware Foundation, and then also into the funded projects and the publicly funded projects by the CHIPS EU. And the next step now is we want to see it into products, right? And this is the next phase that they are funding. What I observe is that the non-core IP didn't significantly improve for the last 10 years. Essentially, like, you can get your uncore IP, but when it comes to like memory controllers, etc., we're still lagging behind. I think there might be more investment, but I think it's already on a good trajectory. The main challenges that I see in general is the sustainability, obviously, of open source projects, like what happens if the public funding goes away, and how can we make sure that it's really adopted. Like, I don't want to say like every product should be built on open source IP, but I think if we want to make it usable, that you just pick some IP, and because you don't want to buy a UART IP, you just want to take one that's already there, that's well established. I think it, and this is what FOSSi Foundation is also working on, make it more appealing and more easy to adapt. On open source EDA, everyone knows this is highly specific tools. They have a very niche user base. I think in the room everyone thinks you're not niche, but I think it's a very niche set of tools. Open source tools have been around since the 80s, right? The layout tool Magic has been around since 1985, I think. It was open source from the beginning. We also have a lot of other tools, and they are also like this. A strong community in Europe, I think. If you look at USYS, which is the predominant synthesis tools, is from Claire Wolf in Austria. But there's many other highlights in general. I think open source EDA is much broader adopted than people think. Because most people think about chip design like the layout tools, right? But if you look into verification, like Verilator, I think it's hugely adopted in industry. Like, I think every team uses Verilator because it makes it very easy to run CI/CD, like your continuous integration, without the need of your license server and the large number of licenses for simulation tools, just run regression tests. So I see a huge adoption, and this is also open source EDA tools, right? If you look into the whole ecosystem of Python-based verification tools like CocoDB, PyUVM, there's a lot of tools. I don't want to say like this is what industry standard, but they have a lot of adoption already, right? OpenRoad was a funded project in the US. It's still the predominant tool. It's the tool flow, integrating users front end and implementing the back end tools. The promise is like a full chip design tool flow in 24 hours. I think we are getting there. The project's not, it is completed, but it's still ongoing work, obviously. And I think this definitely demonstrated open source EDA has some good impact already and should see more intensified attraction also by funding bodies, because I think it's really imperative for us to also think about this part of chip design. So last year, 2 years ago already, last year, we published an open letter together with Luca Benini and a few others that got over 500 signatories, just making the main arguments that I'm making about EDA and the need for open source EDA for academia. In academia, I think if we want to get more students, we need to have tools with a low barrier. That's what we argued for. We should be able to collaborate on those tools. We should be able to exchange designs without any problems. And also, like, the whole idea that we can have new innovations on the tooling itself, I think is very appealing. And this letter obviously had a target. The target was European Commission. We had already some funding in Germany. It was essentially making the argument that we should see broader investment into open source EDA. And then we were tasked last year by the Chip Joint undertaking, Georgi presented yesterday, with the goal of supporting funding decisions to define a roadmap. Like, what are the gaps in open source EDA? Where should the Commission put funding into, and how can we progress this ecosystem to support the goals of the CHIPS Act? Like, everything that we do is really in the spirit of the CHIPS Act here. It was a very intensive community effort because we didn't have much time. It was over summer. So you can find it, I think I forgot the link. You can find it on the internet on our webpage. It just summarizes in very detail what the state of the art is in open source EDA, what the gaps are, what we need to, especially in the domains that are very relevant for key European industries, like tools like where you can design a very specialized tool flow, for example, for automotive, from requirement capturing to the actual design, integrate everything into one tool flow. Those kind of things we highlight and describe a little bit more in this. And we were very lucky and happy to see that it got adopted in a call. They asked us also to define 3 actions that we think that are important. I summarized also the impact that we defined for them on the goals that I summarized earlier. So the first one is, and this is, I think, something very important for Europe, especially analog and mixed signal design. This is something where Europe still has a much stronger position than in other parts of the ecosystem. And being able to use like the IHP BiCMOS process, which is very interesting for this area. 130 nanometers is also not that bad. You are actually already there to be able to design and fully analog or mixed signal design at the moment. Anyhow, we think there should be more investment in this area to complete like the last gaps. There's some parts missing, obviously, that are very important if you're doing analog design, but with some funding, I think we can improve this significantly. The impact will be, especially on the key industries, I think will be very, very huge. So it will be much easier for companies to do analog design without the need of proprietary tools, just to kickstart their whole ambition in chip design. On talents, in general, the problem is that in analog, even in Europe, I think the amount of analog trained talent is much smaller. So we will see. The second action that we defined is on productivity, interoperability, and verification, because I think the Draghi report summarized that the productivity is one of the main gaps. So we identified this as an area we think, especially if we talk about talents, like creating productivity, like talent that is already has the right spirit around productivity should be a focus area. The last one is the digital design. That's obviously something that we want more in Europe, but this is also the one where we have the largest gap in the open source tooling, I think, if you talk about very advanced nodes. All this was turned into a call. The call already closed, so I'm a couple of weeks too late to invite you. There was in the Chips for Europe initiative, in the Chips for Undertaking, there was a 20 million budget allocated to this call. It had exactly those three focus areas that we identified as call topics: digital stock design, analog, and productivity. The deadline ended on April 29, and we hope that the projects will then start next year. In the joint undertaking, as was highlighted yesterday, 20 million means this is the European contribution, and the national funding agencies contribute the same amount for each of the partners. So you have a total of 40 million. The last thing is the open source PDKs. It was very great to see that Google invested heavily in this in 2020. They pushed for easy access to chip design. They worked together with Skywater Fab, created a 130 nanometer PDK. In Europe, the IHP Fab in Eastern Germany. Later came out, I think, 3 years ago with their 130 nanometer BiCMOS process. They also have a CMOS part of it. And there's some activity there. We see that there's the potential for more open source PDKs, but it's definitely the area where we need also more attention on in future. Especially if we think about the access to it, right? The open source PDK is nice. There's also many others that are not really for manufacturing, just for research or for playing around. But the accessibility of fabrication is really important also from an academic point of view. If I tell my students, oh, now I upload it to GitHub, there's a GitHub action, now I can submit it to a multi-project wafer and it will come back in a couple of months. That's really great, right? So we want affordable, regular runs. Tiny tapeout is very important in this area. If you haven't heard about it, you should check it out. It even splits up the multi-project wafer into smaller design parts, design elements, blocks, and you can just submit for a couple of $100. You can get your own board with your own design, just sharing one larger design for you. So the goal that we have is one student, one chip, I think. You heard about it. We will hear about it today, I think. So we just published another open letter earlier this year. That's how we communicate in Europe, right, with open letters. So we were asking for sustainable access because over the last weeks there were some issues with the access to the US PDKs. And from a European perspective, I think we need something like one student, one chip, where every student that studies gets a voucher and can do a tape out on one of the open source PDKs. I think this should be something worth funding in Europe. If you haven't signed yet, please sign. In summary, I want to make a very provocative statement, I think. I'm a little bit too young to remember, because that was when I was born. There was this area of demystification of chip design, right? So you had this VLSI design wave in the early 80s, late 70s, right, when the EDA tools were invented, essentially. Yeah, before that, you only had physicists being able to do chip design. This was when engineers became able to do chip design. And I think the open source wave that we see at the moment could have a similar impact, like not in the same strengths, I think, but a similar impact on the way that people think about chip design. So if you look back, it was physicists that designed chips at the fabs, essentially. With the VLSI design wave, the EDA vendors were founded, right? Like this is how VLSI design even started in the early 80s. And engineers were able to do this. And I think with the open source, now we get to the phase where everybody can do this, right? I don't think everybody can do it, but everyone who's like from a technical field should be able to just go on GitHub, download a couple of tools and do chip design. And I think that's an entirely shift and a more demystification of the entire process. And this should also be the ambition, right? Like, I love that we all go around and tell people how complex our job is. But I think if we want to get more people involved, we shouldn't tell them that it's like mystic stuff, right? It's in the end, it's engineering, and I think the open source wave can help making it. And you can see at the DARPA funding, VLSI, it was called a program that enabled this. And you see the similar now, or you saw a couple of years with the IDEA, which was funding the Open Road project, right? This is the German side. We also follow behind a little bit, but we also had a similar project in Germany, like VLSI, which had a huge impact in universities in Germany, and we now have another set of calls focusing entirely on open source tooling. So I think there's some similarities, right? Also, if you think, like before the VLSI wave and before MEET started the Moses project, which is multi-project wafers, which was copied in Euro practice in Europe, like this shifted you from wafers to MPWs and making the next step, and this is what we see now, into stuff like tiny tape out where you just share MPWs even to have very small gate counts, but just the availability of production. Yeah, I think if you think about it a little bit, you can see some similarities, and I would strongly advocate to take it more serious than some people do. That's it from my side. I just want to highlight that we have the annual conference, OurConf, again this year in September in Valencia. It's the 14th edition of it, I think. It's a very great opportunity to just meet people that work in this area, to exchange a little bit, to just get curious and have some fun. It's in September in Valencia. That's it from my side. Thank you very much. Enjoy the day. It's pretty early still for me. And I hope if you have any questions, come back to me. I think we can discuss a lot of the stuff that I presented and how you think about the demystification. Thank you.